So today we are going to start amines. Amines, so which is one functional group. So derivative, actually this is derivatives of ammonia. Okay, so derivatives of ammonia and obtained by replacement of one, two, and all the three hydrogen. Okay, so this is actually it is a derivatives of ammonia. Okay, so it's obtained by or it's obtained by all the replacing one, two, or all the three hydrogen. Okay, all the three hydrogen by hydrogen atoms. Hydrogen means it's hydrogen atoms by um, uh, alkyl group. Okay, by or aryl, alkyl or aryl groups. So it is derivatives of ammonia obtained by replacing one, two, or all three hydrogen atoms by alkyl or aryl group. If, for example, if you take this ammonia, so this is ammonia, no? So if one of the hydrogen is replaced, you will get okay RNH2. One of the hydrogen is replaced by here alkyl group. Okay, so this is one of the hydrogen. So if two hydrogen are replaced, you will get R2NH. Okay. If three hydrogens are replaced, you will get R3N. So for N, we know that so it has one lone pair of electrons. Okay. So this is amine. So this is primary amine and this is secondary amine and this one it is a tertiary amine. Okay, so this is primary amine, secondary amine, and then this one it's a tertiary. Okay, so what is the use of this and why we are learning about this means all the proteins and the vitamins or nothing but it's an amines. Okay, alkaloids, hormones, polymers, dyes, drugs, antiseptic. So all contains this amines. So it is very important to know about this amines. Okay. So this one, especially the medicine Benadryl, you are familiar with the Benadryl. So it is a amines a drug by amines. Okay. The salt, if you are seeing the salt NH3, this is ammonia. All the three hydrogens are replaced by alkyl or aryl groups. Then apart from that, so we will get quaternary salt also. So quaternary means it's four hydrogen will be there. Okay, so that we will learn in the later part of the lesson. Mm, okay, so we will see. This is all about amines. If you want to see the structures, okay, if you want to learn about the structure of amine, um, this is the structure. Amine means it's ammonia. So it will be like this. So all the three hydrogens are there. If it is a tertiary amine means if all the three hydrogen are replaced, so you will get this is a tertiary amine. Okay, so this is a tertiary amine. So in this nitrogen in amines is trivalent. Okay, so this is nitrogen in amine is this one is a it's a trivalent. It's a trivalent and carries one lone pair of electrons. One lone pair of electrons. Oxygen, which contains two lone pair of electrons. Nitrogen, which has only one unshared pair of electrons. Okay. So if you are seeing the configuration, the nitrogen, its atomic number is 7. So that means it's 1s2, 1s2, 2s2, 2p3. So this is the configuration. Okay. So this one it's a configuration. So if you are writing the hybridization, so we are going to take only this. Then the structure will be this is a 2s2, 2s2 which has two electrons. Okay, then it's a 2p3. So all the p orbitals, all the three orbitals which has one electron. Okay. So nitrogen actually it is sp3 hybridized. sp3. Okay. So it is sp3. Then it's a pyramidal structure. If you are seeing that the structure pyramidal. Okay, so because if you are seeing that, okay, so it's nitrogen, one lone pair is there, so it's look like it's a pyramidal. The shape is it's a pyramidal. Then each of the three sp3 hybridized orbitals of nitrogen overlap with orbitals of hydrogen here. Okay, so three sp3, no, so which is hybridized orbitals, which is overlap with orbitals of hydrogen or carbon, which depends on the composition of amines. Okay, so for this sp3, no, so which is overlap with either hydrogen in ammonia, but an alkyl group in other amines. Okay, so the so then due to the presence of unpaired electrons, angle is which is less than 109.5. Okay, so for example, if you take this one, amine, so this is R1 and R2 and R3. So one lone pair of electrons are there. So here the angle is 109 degrees. Okay, so அதாவது carbon, nitrogen, uh, the electron. Okay, so this one, so this is this carbon, this nitrogen, and this electron pair is it is less than 109. Okay, that means it is a 108 degree. Carbon, nitrogen, this electron, lone pair of electrons, the angle is it's 108, it's less than 109. So that means 109 it is for tetrahedral, but so this one is it's a trigonal. Okay. So this is all the structure of amines. Then if you take classification, understood? No, any doubt for any structure? Okay, so why it is 108 means so there will be that means it's less than 109. That means the angle 109 means it is an angle for tetrahedral. So here why it is 108 means the repulsion between, so this is a bond pair. Okay, bond pair and lone pair. So that is what the angle is. It's reduced to 108. Okay, okay. So the next one we'll see about classification. What are the classification of amines that we will see? Classification. If you take classification, it's not, it's a primary, secondary, and tertiary amines. Uh, so we will get NH3. So if you take it NH3, so from this, it's a we will get it's a primary. RNH2 means it's a primary amine. Then from this we will get R1, R and R dash NH. So this is secondary, and from this, so we will get tertiary. R, R dash, N, R double dash. Okay, so this is tertiary. Okay, so some example we will see that primary amines. If you take a primary amines, if you take a primary amine, there is RNH2, which is a primary amine. No? So this is a general one. If you want to say the specific, okay, CH3, CH2, CH2, NH2. So this is a primary. Okay, and then if you take a secondary, CH3, CH, CH3, CH2N, sorry, this is also, it's a primary. So why it is a primary means, so this is amino group, no? Here in this, only one hydrogen is replaced by this full group. Here is a primary chain, this one is a secondary chain, but both are replaced one hydrogen in ammonia. So this is primary, this is also primary. So don't think that this is a secondary because of this CH, but this alkyl group is a secondary. That is, this one is a secondary carbon. But amine, if you are considering as a amine, so this is a primary amine. You understood the difference? Understood? This one, this alkyl part is, here it's a alkyl part is also primary, but here the alkyl part is a secondary. But if you are taking amine, both are primary. Okay. So then this is a primary amine. Then if you take a secondary, okay, if you take a secondary amines, secondary amines means two hydrogen in ammonia will be replaced like this, no? Two hydrogen. So that means it's a CH3, CH2, NH, CH3. So this is a secondary. Why it is a secondary? Two hydrogens are replaced by two alkyl groups. If you take this one, so this is also secondary. Okay, so this is two alkyl groups. That's fine. This is two alkyl group which is replaced by the two hydrogen which is replaced by two alkyl groups. So both are secondary. Okay. And then third classification, tertiary. Third classification, it is tertiary. That is N, R, R dash, R double dash. Okay. So this is tertiary amine. So if you want to see the example for this, we will see CH3, CH2, CH2, N. Okay, here one CH3, here CH2, CH3. How do you give name? Then we will see later. So this is tertiary. Why it is a tertiary? Because all the three hydrogen in ammonia are replaced by three alkyl groups. Okay, this is also tertiary. This is also tertiary. Okay, so this is tertiary amines. Then apart from that, still some of the classification are there. It's aryl amines. Up to this, we are seeing only aliphatic amines. If you are seeing aryl amines, benzene group will be attached. Okay, aryl amines having NH2 group directly attached to the benzene ring. Okay, so they are named as derivatives of aniline. Okay, so if your aryl group is replaced, one hydrogen in ammonia, so you will get this one, you know, aminobenzene, or this is aniline. So aniline is actually, it's an accepted UPSD. Okay, yeah. So this is aryl amine. So this is also aryl amine. These are all comes under aryl amine. It's NH2 CH3. So this is through 2-methylamine. Okay, so this is 2-methylamine. And then if you take this one, NH. Okay, NH, um, CH, CH3, CH3. So this is actually, it's a secondary amine, but still it is aryl. Aryl amine is secondary amine. This one is isopropyl benzanamine. Okay. So this is fully, it's an aryl amine. So if a benzene ring is attached, benzene ring is replaced one hydrogen in ammonia. So that is called, it's aryl amine. Okay. Again, some more example I'll give. It's N CH3 twice. So this is actually tertiary amine. Okay, because all the three hydrogen are replaced. Name of this one is NN dimethyl I will give how to write the name. Okay, benzyl, benzanone. Benzanone. Again, two hydrogen atom if it's replaced by um, two benzene ring. Okay, so this one diphenyl, diphenylamine. So, but everything comes under arylamines. This is also one of the classification. Okay, then one more classification, hydrocyclic amines. Hydrocyclic amines. Uh, so hydrogen. So this is heterocyclic. The name of this one is, this is also comes under amine, but heterocyclic amine. This is pyrrole. Okay, the name of this one is it's pyrrole. Then um, yeah, this is pyridine. This is pyridine. Okay, this is pyridine. So this is also amines. Okay, comes under, it's an amine. Okay, but heterocyclic amine. Okay, then one last classification, simple and mixed amines. Ethers பார்த்தோம் இல்லையா? So the same way here also it's a simple and mixed amines. If all the alkyl groups attached to a nitrogen atom are similar or same, then it is called it's a simple. Okay, so if it is a different, then it is called it's a mixed amines. If, for example, if it is simple amines, it's a CH3 twice NH. Okay, here the both the groups are this CH3 group, so it is a simple amine. And if it is like this, also it is a simple. Okay, so the two alkyl groups are same. That is a simple. Okay, even if it is like this, C6H5, all the three aryl groups. So this is also same, no? So these are all simple amines. If it is mixed amines means both alkyl groups are different. So CMH3, CH, C2H5. Okay, it is a mixed amine. Otherwise, it may be like this, C6H5, NH, C2H5. Okay, or it may be different like this CH3, C2H5, then it's a C6H5. So this is all mixed. Okay, so not all the alkyl groups are same. So that is a mixed amine. So this is simple amines. Understood? So the classification, it's a classification, that's all. Okay, yeah. Understood? Now the in naming IUPAC, that is nomenclature, it's a little bit different from other functional groups. So I will take this one. So again, this about this amine also I have given in that video. So if you are not go through that, so please listen now. IUPAC names. So how you are going to give IUPAC or common name also we can see. Instead of IUPAC, it is better to give as it's a nomenclature. Um, in IUPAC system, okay, amines are named as, it's named as alkanamines. Okay, alkanamines. How these alkanamines are derived? Alkane, alkane instead of E, so we are writing amines. Okay, so this is alkanamines. Previously, we are naming like that. If you are seeing CH3NH2, CH3NH2. So what is this? Methane. No, it's a methane. So it is methane. We should not write N. Instead, we have to write amine, methanamine. Okay, then C2H5NH2. So this is ethane. No, it is ethane amine, ethanamine. Okay, so if it is a higher member, select we have to select longest chain which contains amino group. Okay, amino group should get the lowest number. For example, CH3, NH, CH3, sorry, CH3, CH, CH3, CH, CH3. Here it is NH2. Now we have to select the longest chain, which is the longest chain which contains three carbon. That means it's a propane. No, it's propane. Instead of writing E, we have to write amine. No, but here the amino group is in the second carbon. Okay, so propan to amine. Propan to amine. So this is what we have to write. Okay, this is one thing. Uh, okay, this is one thing. So for another one, if you take this one, H2N, two amino groups are there. CH2, CH2, NH2. This is the primary amine actually because NH2 is there, but here there are two amino groups are there. Okay, so in that case we have to select the longest chain. Here the longest chain is ethane, so you put ethane. Okay, we have to write um, here if in case of more than one amino group is present at a different position, the letter E, okay, of the hydrocarbon partner is retained. Understood? Here we have to write E. But in this case, no, so we are not writing. So because there is only one amino group. But in this example, so there are two amino group at a different position. In that case, we have to write the E in hydrocarbon part. Okay, ethane 1,2 diamine. If you are writing E here, the name will be different. Okay, you should not write E in this case, these two cases. But if more than one amino groups are present, uh, okay, so we have to write E. Understood? Please answer for this one. Uh, if more than one is present, so we have to retain the E in hydrocarbon part. So the name of this one is ethane 1,2 diamine. Okay, 1,2 diamine. So each alkyl group, suppose if you are taking this is one example. This is one example. Okay, the next example, CH3 NH, it's CH2 CH3. This is the secondary amine, right? If how we are going to give name for these names, each alkyl group, this is one alkyl group and this is one alkyl group. Each alkyl group bonded to nitrogen atom is named as N alkyl group. Okay, the name of this one is N methyl. Okay, N methyl ethanamine. Ethanamine. Here you should not write E. Okay, so this part, so here if you are selecting the longest chain, it is ethane. So it is ethanamine. But but we have to write this, mention this alkyl group also, no. So this alkyl group we have to mention this as N methyl ethanamine. Understood? So N methyl ethanamine. Again, if you are seeing this, wait, I will give another example. N-methyl methanamine. So this one, if you take this one, CH3 N. Okay, this is a tertiary amine. How will you give name for this? Here the longest chain, anything it may be a longest, it is only one carbon. So it is methanamine. Methanamine, but what methanamine? So here the two alkyl groups are present. Okay, so in the two alkyl groups are, apart from this, two alkyl groups are attached to nitrogen atom. So we have to write NN dimethyl. Okay, NN dimethyl methanamine. Understood? So in the common name, yes, in the common name we will write three methyl groups are there. So we will write three methyl amine. So this is a common, but common name we will not follow. This is the common name. But IUPAC, so this is IUPAC. NN dimethyl methanamine. Understood? So we have to select the longest chain. Longest chain you have to select. Okay. Now this. So wait, I will give another example. Um, CH3 N CH3 here C2H5. So here which is longest? So this is the long chain. No, so it should end with ethanamine. Ethanamine, but the two alkyl groups are attached with this carbon. So NN dimethyl ethanamine. Okay, again C2H5 N. Here one C2H5. Then here it's a CH2, 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 CH3. So comparing all these things, this is the longest chain. So that means butanamine. Yes. Uh, NN di, okay, diethyl butanamine. Okay, okay. So this is what we have to give name. Uh, it's a normally will give name this one, but if you're the compound like this NH2 CH2 CH double bond CH2. Okay, so this is actually it's an allyl group. Okay, because this is a star carbon which is attached to the double bond carbon. Okay, so this one, how will you give name? It's actually it is propene. Yeah, so pro two in propane amine propene two. Second position, uh, double bond is there. Okay, first carbon, this is second carbon. In second carbon, double bond is there. So prop 2 in amine. Okay, because this is star carbon, we have to give the lowest number. This is functional group is attached. So this is number one, this is number two, and this one is number three. Okay, this one CH2 six times NH2. How will you give name this one? Two uh, amino groups are there, then we have to retain E. Okay, so six carbon is there, so it is hexane. Okay, 1,2 diamine. I hope that you are now familiar with the UPSC, right? UPSC of aliphatic amines we have seen. Anyone has any doubt, ba? Or there, no doubt for anyone. Okay, so we'll go for aryl amines. How we are going to give name for aryl amine? So this one, benzene ring with NH2. So this is aniline. It's a common accepted UPSC name. It is aniline. But this is actually it is a benzene. Okay, benzene. Don't write E. I mean benzene. Okay, if it is like this, one amino group is there, then one CH3 group is there. Okay, here we have to give priority to amino group. Okay, so priority to amino group means this carbon is number one. So then this is number two. Okay, so you can write this as 2 methyl aniline. Okay, 2 methyl aniline, or in common name it's orthotoluidine. Okay, okay, so this is what we have to give name for aryl amines also. So this also we can give name. This one, um, it's NCH3 twice. So actually this is a tertiary amine. Actually this one it's an aniline. In aniline, two hydrogens are replaced by two methyl group. So how will you write the UPSC? NN dimethyl benzene. Okay, NN dimethyl benzene. Understood. Understood. Any doubt? Hope that now you are clear. So you will have more examples in a book. Please go through them. Okay. Okay. So we completed a UPSC and the structure. Now we will see the preparation. Let's see, it's a preparation. One a reminder. 26th we have test unit test 1. Okay, 26th May, unit test 1. Unit test 1, haloalkanes and arenes. So notes I sent, video is there, so please go through that, and then uh, you prepare and write the answer. I think it's Sunday, so I'll put a question paper by morning 11 o'clock. The same time I'll put the question paper, send the question paper through drive. So you please write the answer and convert that into PDF and then send. So because in the last minute notes, I may forget or some of you are leaving. So that's what I told now. In the preparation of amines, so we have actually seven methods are there for preparing this. It's easy only. Because already we learned it's the reduction of nitro compounds. First one it is reduction of nitro compounds. Nitro compounds means what is the functional group? Please, any one of you tell me. Nitro means what is the functional group? Functional group nitro. How we are representing? How we are writing nitro? Yes, NO2 group. Okay, so NO2 means it's a nitro. So the reduction of nitro compounds by passing hydrogen and in the presence of nickel, palladium or platinum in acidic medium, it gives amine. Okay, or NO2 hydrogen in the presence of nickel, either nickel, palladium or platinum. Platinum. So we'll get amine RNH2. Okay, so the reduction of nitrocompounds. Either we can use hydrogen or we can use this also or NO2. Okay, SnHCl. SnHCl. So we will get RNH3. Okay, again in basic medium, so we will get RNH. Okay, primary amine. So in the same way, we can prepare for aromatic amines also. So this is nitrobenzene. So we are going to take its nitrobenzene, the same SnHCl and the base. We will get aromatic amine, that is aniline. Okay, either we can use this one or we can use hydrogen with palladium. Okay, hydrogen with palladium or platinum or nickel, anything. So it will be reduced to primary amine. So that is aniline. Okay, so here this one SnHCl, or we can use this also SnHCl, or it's FeHCl also we can use. So here the FeHCl is the preferable method because here the byproduct obtained is FeCl2, uh, which is which is released, okay, on hydrolysis, which will release hydrochloric acid. That hydrochloric acid will be used for initiation. Okay, yeah. So that is Fe. If you are using FeHCl, the byproduct obtained is FeCl2, which on hydrolysis it gives HCl. This HCl will be used to initiate this reaction. Okay, so this is preferable method. Okay, so this is preferable method in nitrocompounds. Okay, so this is first method. Second one, um, ammonialysis of alkyl halide. Ammonialysis of alkyl halides. What is ammonialysis? Here alkyl halides undergo nucleophilic substitution reaction, that means SN2, with ammonia, forming primary amines, forming amines. So we will get ammonialysis means it's, see that NH3. Suppose if you take NH3, so this is nucleophile. Because why it is a nucleophile? It has one lone pair of electrons. Okay, so when this one react with alkyl halide, so here because of electronegativity difference, so it will get partial positive. This one it's a positive and this is negative. So now what will happen? This nitrogen, no, it will transfer its electron to this R and it becomes RNH3 X. Okay, so this is actually ammonium salt. Ammonia with alkyl halide will get ammonium salt. Again, this one, no, it will this substituted ammonium salt. This ammonium salt, if you are using excess of ammonia, okay, you are using excess, you will get primary amine. Primary amine with then ammonium salt. Okay, so we get primary amine if you are using excess of ammonia. Okay, so actually the reaction will not stop up to this. The primary amines, so it is they know actually these primary amines are more basic than ammonia. We know that ammonia is a basic, but the primary amines are still it's a basic. So which further reacts with alkyl halide, okay, which gives a secondary amine and then it's a tertiary amine. So that means it's excess of ammonia is there, we will get primary amine. So this primary amine, it will react with alkyl halide. Okay, alkyl halide, it gives R2NH. So this is a secondary amine. Okay, this is a secondary amine. Here it's excess. If excess of alkyl halide means we will get primary, secondary, and tertiary. Okay, again which one react with alkyl halide, so we will get R3N. Again it will react with one more molecule of alkyl halide, so we will get ammonium salt. Understood? If this is a quaternary ammonium salt. Okay, quaternary ammonium salt. அதாவது if we that means if we want to prepare primary amine, so we need to use excess of ammonia. I will write here. Um, if primary amine is needed, okay, is needed. Um, is the major product. We need to use excess ammonia. Excess ammonia. Okay. அப்படி இல்லாம if we want to make this quaternary salt, we need to use excess of alkyl halide. Okay, the order of reactivity, is Ri, RCl, RBr, and then R. Okay. So mostly RF it's not it will not be there because of high electronegativity. Okay. So the order of reactivity is, if you are using Ri, it will go faster. Okay, the reaction will be faster. Then RCl, then RBr. Okay, so this is the second method by which we can prepare amines. Okay, ammonolysis of alkyl halide. So there is a second method. Okay, so third method. Now what is the third method? So third method is, it is reduction of nitriles. What do you mean by nitriles? Nitriles means, what is nitriles? So it's a CN. Okay, cyanide. So this is nitrile. So alkyl nitriles are CN, alkyl nitriles, in the presence of the reaction on reduction on nitriles on reduction with lithium aluminum hydride or hydrogen or nickel or lithium aluminum hydride, okay, or sodium amalgam alcohol. So this is the condition. Then this will be reduced to primary amines RCH2NH2. Okay. So this is on reduction of nitriles. The same thing we can use for aryl amine also, aryl cyanide also. That is the CN, uh, hydrogen with platinum or palladium or nickel. Okay. So addition of hydrogen is the reduction, no? So it will add two hydrogen with the carbon and two with nitrogen. We will get a primary amine. Okay. So this is reduction of nitriles. And here sodium amalgam and alcohol, which is used as a reducing agent. Okay. And this one, it is called, it's Mendel's reduction. Mendes reduction. Okay, so this is the third method by which amines are prepared. Okay, first one, reduction of nitro compound, then ammonialysis of alkyl halide, third one, reduction of nitrites, right? Then fourth one, reduction of amides. Amides means what group? CONH2 group is it's an amide. Okay. So reduction of amide with lithium aluminum hydride. That is RCONH2 with the lithium aluminum hydride, and then followed by hydrolysis. You get CH2 primary amines. All reduction now. Okay. So if you are taking aryl CONH2, again the same condition, so we will get CH2, right? So this is reduction of amides. They follow me now. Okay. So this is the fourth method. So all easy method only, reduction now. So the next two methods only it will be different one. Next method after this reduction of amides. So next again naming reaction. It's Gabriel thalamide synthesis. Naming reaction comes under naming reaction. Gabriel. Okay, Gabriel thalamide synthesis. Gabriel thalamide synthesis here, which is used for the preparation of primary amines, especially it's a primary amines. So here the thalamide, okay, so on treatment with ethanolic or alcoholic potassium hydroxide. So what is the thalamide? Yesterday in the on reaction we have seen what it's a thalamide. It's a C double bond O, C double bond O, then NH. This is thalamide. Okay, so this is thalamide, which on alcoholic KOH, on react with the alcoholic KOH, it forms a potassium salt. Okay, it forms potassium salt as an intermediate product. It's a C double bond O, then C double bond O N K. This is the salt of thalamide. What will happen means, so this as an intermediate. When this will react with alkyl halide, okay, we will get the same thing. So you don't change anything here. Okay, so here instead of this K now, which is replaced by alkyl group NR. Okay, this one on hydrolysis with the NaOH gives primary amine, and this one it's COONA, COONA plus primary amine or NH2. Okay, so this is primary. So this is a naming reaction. Um, Aromatic amines, this method. Okay, so in this method, aromatic primary amines cannot be prepared by this method. Okay, aromatic primary amines are not prepared by this method. Okay, then what is the reason? So because aryl halide do not undergo If you are for that, we need to take aryl halide, no, instead of alkyl halide, we need to take aryl halide. That aryl halide, so which undergo nucleophilic substitution with anion anion formed. So this one. So if you are taking aryl halide, so it will undergo nucleophilic substitution reaction. So that is what it is not method for preparing aromatic primary amines. This is best for preparing aliphatic primary amines. Okay, this is one of the naming method. Thalamide, Gabriel thalamide. It's a synthesis. Okay, so five methods we have seen. First one, reduction of nitro compounds, ammonialysis of alkyl halide, reduction of nitrile, reduction of amide, and then Gabriel thalamide. So this is naming reaction. Next one, which also comes under naming reaction, Hoffman, Hoffman bromamide, Hoffman bromamide degradation reaction. What do you mean by degradation? Degradation means the number of carbon in a substrate, no, will be less in when we are getting the product. Okay, so Hoffman bromamide degradation. So that means that you are taking amide, RCONH2. So this is amide. When it is treated with the bromine and NaOH, okay, so we will get primary amine RNH2 plus Na2, sorry, NaBr plus Na2CO3. Here, if you are seeing, no, so here one carbon is extra. Here there is no carbon. Only the alkyl group it's retained. The carbon will be replaced. Okay. So this is Hoffman bromamide degradation reactions. Why it is a degradation means the number of carbon will be reduced. Okay, so the same way we can write for aryl, also aryl amide, it's the CONH2, okay, with the NaOH and Br, so we will get amine. Okay, the same way, so everything it will be same for this also to NaBr plus Na2SO3, Na2CO3 plus water. So this one, first one it is for aliphatic, second one it is for aromatic. But both are Hoffman bromamide degradation reaction. Understood? This is the preparation. So there are preparations are there. Okay, methods of preparations are there. Reduction of nitro compound, reduction of nitrile, reduction of amide, then ammonia-lysis of alkyl halide, Gabriel thalamide, and Hoffman bromamide. So in the six reaction you two reactions வந்து naming reaction வந்து வந்துருச்சு. Okay. So then today you'll see the physical properties and then stuff. So next day we'll see the chemical properties, but physical properties today we'll see. Okay. The same thing, physical properties, everything we have seen no already. The same thing we are going to see here. If you are taking a physical properties, if you take a state, okay, if you take a state, it's a lower aliphatic amines or gases. Lower aliphatic amines or gases. Then primary amine up to 3 carbon. Okay, up to 3 carbon for liquids. are liquids and the higher ones are solid. Okay, so this is all about its state. Again, aryl amine, if you take aryl amine or aniline, so they are usually they are colorless, but they get colored on storage due to atmospheric oxidation. Okay, so mostly colorless, but when will it get colored means when it exposed to light, so it will become a um, dirty color. Okay, so that is generally when it is colorless, when it is pure form. Then boiling point, all amines except the tertiary amines, the primary and secondary amines are capable of forming intermolecular hydrogen bond. So it will primary and secondary amines are more boiling point. For example, so this is primary amine. So it forms a hydrogen bond with next amine. Okay, this is a H bond. Okay, this one is it's a H bond. Intermolecular hydrogen bonding in primary amines. Okay, yeah. All amines except the tertiary. Tertiary amines they will not form a H bond because there will be no hydrogens or there in tertiary. So both primary and the secondary amines they form a hydrogen bond. So its boiling point will be higher. Okay, the amines have higher boiling point. Higher boiling point due to H bond. Higher boiling point due to H bond. Okay, then amines have, but amines have low boiling point then compared to alcohols or carboxylic acid. Okay, they have a higher boiling point. It's okay because of H bond, but its boiling point will be lower than that of alcohols and carboxylic acids. So that means boiling point for amines or less than that of alcohols, then carboxylic acids. Okay, yeah. So this is a boiling point. Then again, if you take the solubility also for same reason, due to H bond. Okay, so the lower amines are soluble in water, but the solubility will decrease when the molecular mass it will increase. Okay, uh, again it's due to H bond, due to H bond. So this is water, and this one it is a H bond. Okay, so this is about the solubility. If you are taking aromatic amines, which is insoluble in water, aromatic amine insoluble in, but soluble in alcohol and ether alcohol and benzene. Okay, so this is all about its physical properties.